Hello guys, today we're going to solve this question. The question is a little long. In a frequency table, the upper boundary of each class interval has a constant ratio to the lower boundary, so that the GM is geometric mean may be expressed by the formula logG is equals to x0 plus c0 by n summation of I1 by I minus 1, where x0 is the logarithmic of the mid values of the first interval and c0 is the logarithm of the ratio between upper and lower boundaries. Okay, I hope you see the question clearly. Okay, replicate this thing. Okay, you have to put this thing, and everything is written in the question. So now we put the thing. We let what we do is answer. We let the ith class be denoted. So we let the ith class be denoted by Li. Okay, with corresponding frequency of I. Okay, in which one, and now I is equals to 1 2 3 unit, and let the constant ratio between now let the constant ratio. Okay, CNST constant ratio between upper and lower limit V. Okay, so we'll now write the constant ratio. Okay, we will let the constant ratio be lambda. So from upper limit, that is L2 by L1. Okay, we'll just take two limit. Okay, one is upper, one is lower limit, and L2 is upper, L1 is lower limit, so that will be equal to L3 by L2 and is equal to L4 by L3, and we just assume this thing. Okay, this is equal to Li by Li minus 1. Okay, this is because this is one smaller, so we write this. Okay, which is let this is lambda, say. Okay, so midpoint. Okay, you take midpoint. Formula for midpoint is x1 is equal to L1 plus L2 by 2, and this will be equal to 1 by 2, and L1 is L1 and L2 is L1 times lambda. Okay, so I'll write L1 times lambda, and that will be equal to 1 by 2 L1 1 plus lambda. Okay, this is 1 plus lambda. So now x2, that will be equals to L2 plus L3 by 2, and that will be equal to 1 by 2 and L2 plus L3. Okay, L3 lambda. Sorry, L2, L3. Okay. L2 plus L3, and we can write 1 by 2 L2 plus what is L3? L3 means L2 times lambda, so lambda L2. So again, what we can write is L2 means L1 times lambda. So we'll put this. So L2 is L1 times lambda plus lambda is lambda there. So L2 means L1 times lambda. Okay, so it will be equal to 1 by 2. L1 is common, and lambda plus lambda square. Okay, so now we copy this thing. Now xi, for xi, what we get is from x1, what we get was 1 by 2 L1 1 plus lambda, and from the x2 it was 1 by 2 delta lambda plus lambda square. So xi will be 1 by 2 L1 1 plus lambda I minus 1. Okay, just like we did in there's like it was first 1 by 2 from here. You can see from here. Okay, if we take lambda common, we can add this first, or we can directly write like this is L1, this is L1, and this is L1. Okay, so for one term, for x1 this is L1, for x2 this is L1, so for xi this will also be 1 L1. For x1 this is 1 plus lambda, for x2 this is again 1 plus lambda if we take lambda common. Okay, if we take lambda common, this will again be 1 plus lambda. So for xi also this will again be 1 plus lambda. Okay, so here nothing is common. Here if we take 1 plus lambda common, lambda will be here. So if here it will be lambda power I minus 1 is in case of here what we can write is 1 by 2 L1 1 plus lambda, and lambda will be common. I hope you are understanding it enough. Okay, so if you write it by yourself, then you can understand it. It is hard to write everything here. And so 1 plus x is common, like it is same code x1 and x2, so we can write it again code x out here. And L1 is same, we can write L1 also. 1 by 2 is same, so we can write 1 by 2 also. But lambda is different. Here there is no lambda, okay? But here is lambda. Here is lambda I mentioned. How it came is here is we can write lambda 0 is 1, so we can write lambda power 0. So in the case of x1, this is lambda 0. Just remember and notice one thing. There is 1, here is 0. Here is 2, here is 1, okay? If nothing, there is 1, okay? Lambda power 1. So here is I, so here will be I minus y, okay? Simple. This is so much simple. If you just write by it yourself and just understand it. So now we are from the definition of symmetric mean, okay? I I think I already told you this technique to remember the definition of GM. There is just write log in G is equals to and formula for arithmetic mean. Even this is geometric mean, we'll just write formula for arithmetic mean like x 1 by yeah, okay? And we'll just write log here. Simple technique. So this for initial value we'll write just like for ith term we'll write I and xi and fi, okay? Now and log g will be summation fi log in xi. What is the value of xi? Xi here what we got is this, okay? But remember the thing here, there is 1 by 2 L1 1 plus lambda, and this is what it is here, okay? So we can add this lambda power 0 uses take it for understanding the what we can get is here. So this is x1, okay? So we can write x1 and lambda I minus here. So now we will put x1 lambda I minus 1 here. That will be the x1 lambda I minus 1, okay? So divided by n, and we will just separate the thing by the formula of logarithmic summation fi log x1 plus summation fi log lambda I minus 1, okay? And both divided by yeah, okay? Simple and clear. It is clear up here. And now you know that summation fi means total frequency is total number, okay? Total frequency is total number, so we can cancel out. Summation is we know summation fi is equal to yeah, okay? So n and cancel out. So remaining top log g is equal to log x1 plus summation fi by n and log it will just we will have to again use the logarithmic property that the power will become in base, so I minus 1 log lambda, okay? This is simple property of log that we do here, okay? So now log g and log x1, it will be log g and is equal to, and we will let log x1 is x0, okay? And we will let this whole term, okay? Not this whole term, I will let only this term log lambda as c0. We will take log lambda as c0, so that will be c0 by yeah, and the remaining term summation fi I minus 1, okay? And this is what we have to prove, okay? So where c dot is equal to log lambda by n, okay? We will also take n if we have to take but that is not necessary. The c dot is log lambda, okay? And x0 is equal to log x1, okay? So this was what we had to prove, okay? This is simple if you understand it, if you write it by your own hand. Thank you.